All right. Well, welcome everybody. Thank you for joining us for today's Astro-BS. I'm here at my home office. We've got a couple of the stargazing leaders at the Wyoming Stargazing office in Jackson, Matt and Dave. And we got Ryan. Where are you here, Ryan?
Right here.
Why are
New Jersey.
there? Classic. Yes, we're all right here with Zoom together, physically in the space-time. Where is your current location?
In New Jersey, 2 hours time zones away. 2 time zones away.
2 time zones away. Excellent. Well, thanks for joining us, man. It's good to have you. How is your flight out there?
Nice and smooth, no problems. Got home in a little under 8 hours.
Nice. Empty plane, full plane, COVID plane?
The first one was like half full, and then the second one was full.
Everyone was wearing a mask.
Yeah, masks are mandatory for the whole flight.
Yeah, I haven't been on a plane in a long time.
Yeah, this is my first flight since.
Oh wow. Yeah. Well, cool. Glad you made it safely back there, and we'll see you back in Jackson in a couple of weeks.
Absolutely.
All right. Well, what I thought would be cool to talk about today, or at least start talking about today, in terms of astronomical content, is the impending landing of the OSIRIS-REx spacecraft on asteroid Bennu, which is going to happen in 5 days. So this is kind of a historic moment because for the first time, we are going to land a spacecraft temporarily, momentarily, on an asteroid, pick up a little sample of that asteroid and bring it back to Earth in a few years. So I want to share my screen and just kind of give folks a little bit of background on asteroid Bennu, what we're talking about here, and the OSIRIS-REx mission. So it's, like I said, a mission out to this asteroid named Bennu. And we bring up this little timeline here. Let's see if we can make this bigger so we can actually see this.
Oh, there we are.
There we go.
Okay.
All right, so here is kind of a timeline of what's gonna happen. And so, yeah, the sample collection window is fairly small. So we're right here, I think. So they've done all these rehearsals to figure out the best place to land on this asteroid. And they're going to do the first sample collection in just a few days. I wonder if we've got a bigger timeline of everything. So, so I guess, let's see, it looks like August 2018, that was when they first started the initial approach. Arrived at the asteroid in December of 2018. And it's been doing all these flybys and surveys.
Wow.
Let's see, I thought there was a good page that showed, oh yeah, what does this stand for? Maybe we should talk about that. Here we go. The Origins Spectral Interpretation Resource Identification Security Regolith Explorer. That's cool. So regolith, it is referring to the soil composition on the surface of the asteroid. So that's Osiris-Rex, named after the Egyptian god Osiris. Nice.
Oh, that's cool. Spread and understanding of agriculture.
Right, so it's fitting, right? Because we're out here exploring this asteroid because we want to learn about the origins of the solar system. These asteroids are basically like time capsules of the early material that all the planetesimals, which later came together to form planets and everything else in the solar system. So we hope that by bringing some of this asteroid back to Earth, we're going to learn a lot about the origin of the solar system. Let's see here. There was another nice timeline that I wanted to show everybody. So this kind of shows the orbital path, which is pretty cool. So it was actually launched in September 8th, 2016. Arrived at the asteroid just over 2 years later on December 3rd. It's been doing these rehearsal approaches to the asteroid. And the last one was in August 11th. And yeah, and now we are going to do this first sample collection in 5 days, which is pretty cool. So to kind of give you an idea of total distance covered, this thing has traveled 3 billion miles, 3.7 billion miles since 2016. And now it's just 1 kilometer away from Bennu, which is pretty sweet. But not only are we going to actually touch down briefly and collect a sample of this stuff in 5 days, there was a very cool discovery announced last week, which caught my attention, which was this evidence of liquid water flowing on this object or some other object that it might have been attached to at some point, which I think is super cool, right? So these are some of the oldest rocks in the solar system, and we're seeing evidence of liquid water.
Wow. That's nuts.
Right? The other really interesting thing that I was just reading about earlier is that if you look at this image, a lot of the rocks are fairly dark in color. Like this one's kind of dark gray. A lot of these are dark gray. But then there are some really bright colored outliers. It turns out that these rocks can actually be traced back to the asteroid Vesta. And so at some point, there was material that got dispersed off of the asteroid Vesta in the asteroid belt and somehow landed on asteroid Bennu. And now we're actually detecting it on asteroid Bennu. But you can see this nice little spot that they've identified here for the sample collection, kind of devoid of any big rocks. And this is where this thing is going to hover over the surface in 5 days and send a little robotic arm down, get a sample of the asteroid, and then head back to Earth.
So it just hovers there. It doesn't like land on it.
It's just this like really slow descent, and it's just this retractable little scoop that actually touches the surface.
Huh.
Yeah. Yeah, I'll see if I can find a little video of it to show folks. And while I'm looking for that video, I wanted to bring up this next little interesting tidbit of information down here. So the reason we're exploring Bennu is not just because it's one of these time capsules for the early solar system. It's also because that Bennu is going to be coming pretty close to Earth in the next couple hundred years. So close, in fact, there's a 1 in 2,700 chance of asteroid Bennu hitting Earth in the next 200 years, which I guess makes it the second most dangerous asteroid. I'm not sure what the first most dangerous asteroid is. Do you guys know?
Now, is this the one that, so I remember hearing about an asteroid that could potentially hit the Earth sometime in the next, like it was somewhere like between 60 to a couple hundred years. And there was like a very, very small window where if it was any closer than this window where they think it's going to pass by, it might actually hit the Earth. I don't know if that's this one or if that's a different one.
It might have been. I figure we just do a search and find out here.
I think I heard of another asteroid that was supposed to come nearby us like in the next month. Was that?
Oh, really?
Correctly?
I don't know if it was.
About that. Let's see here. So object designation, impact probability. These are all pretty low probabilities here. But yeah, so I guess this is the most dangerous one. I guess they have them listed from, yeah, they have them listed in impact probability. Oh no, they don't.
Oh, they aren't in order.
What's that?
They aren't in order. Hit the arrows by the impact
Oh
probability.
yeah. Let's see. So there's impact probability.
Now hit it again.
Yeah, now it's the rarest at top.
Yeah, there.
Oh yeah. So how do we know the most dangerous? It doesn't give us that option, does it?
Well, no, because they're counting cumulative probability. So that's like if it passes us multiple times.
Right.
Well, yeah, because you have potential impacts, or some of them are numerous.
Right. Let's see.
Wasn't one 2020? A couple, I think.
I'm feeling pretty safe.
Yeah, so there we go. So there's 3 potential impacts from this guy right here in the next 5 years. Oh, here's one in the next 2 years.
That's not nice.
Pretty low probability. That's interesting.
Yeah, I don't even see the one we were just talking about.
Yeah, let me go, oops. So there we go. Now we're, so apparently this, maybe they are, I'm just curious why Bennu is listed second here. And on that last website we just looked at, it said that Bennu was the second most dangerous. So maybe these are listed with most danger to least dangerous.
Right.
Could be.
Oh,
You have
because
to incorporate like size.
yeah,
and
yeah,
stuff.
size and velocity would be danger too.
Yeah. So yeah, I guess this big one, discovered in 1950.
Yeah,
It's not going to be by for another 800 years.
look at the diameter of that thing compared to all the other ones.
Yeah, there you go.
Yeah.
This thing's it's a kilometer and almost a kilometer and a half.
Wow. Okay.
That's a big chunk of rock.
I do remember that one in 2880. I remember watching a Discovery Channel show or something like a decade ago, and they talked about that.
Yeah, I mean, I don't think I need to worry about that, nor about Bennu. But
If we figure out wormholes.
that's right. Thanks for connecting that back to our last discussion. Nice work.
So yeah, I think it's cool that we can get this close to an asteroid, though.
Right?
Yeah. We landed
Yeah.
on,
And,
we landed on a comet.
let's
didn't we?
see.
Not too long, like a few.
I want to see if I can find a picture of like the animation of it actually scooping it up. Animation of OSIRIS-REx mission. Oh, cool. There's all kinds of great stuff. There's a nice gallery. That's what we want. The NASA gallery. Ooh, yeah. Let's see what this is. Here we go. We'll play this for everyone's viewing pleasure.
samples.
As we started to approach Bennu from a distance and it started to fill up the camera field of view, it looked exactly like we thought it would, with a few boulders sticking out. But as we got closer, we expected to see a very sandy surface with maybe a few boulders here and there. And what we saw is very little sand. And we saw these mountains, we saw boulders, we saw rocks, and we saw very few areas that had this sandy surface that we were expecting and what we had designed to.
We have never done this before. We're actually going to collect a sample and bring it back down to Earth for further examination by scientists.
In order to achieve that objective, the OSIRIS-REx spacecraft has been navigating around Bennu for about the last 2 years, studying it in great detail, and also overcoming a number of challenges that Bennu has presented. We were looking for locations on Bennu that were 50 meters in diameter, relatively flat, and covered with fine-grained material. And by fine-grained material, I mean stuff that's the size of a dime or smaller. We realized that there were no sites on Bennu that even came close to meeting this criteria. Everywhere we looked was too small and covered with boulders. So we actually had to fly a number of additional close passes over the asteroid and rethink our entire plan for grabbing the sample. After the additional observations of Bennu, we had to down select to 4 sites and then go back and survey those sites even further to select the final primary sample site.
My first impression of Nightingale is that's the last place I wanted to go. But as we started looking at other sites, we saw that 1, this is probably one of the most sampleable sites, and 2, we were overperforming in our navigation capability and our ability to contact. Natural feature tracking works a lot like the human mind in that we pick up landmarks along the way. As we descend, we look at features on the ground. We program the computer to recognize certain features. It takes a picture, says this feature is not where I expected it to be, it's a little bit off to the side, updates its position based on where it's pointed and where that feature shows up in the camera position.
The tag event is our touch and go event, which is where we'll actually be retrieving the sample from asteroid Bennu. We start with a series of maneuvers, one of them being the checkpoint burn, which is where we'll actually check our position and velocity in relation to the sample site.
And then the match point burn, about 10 minutes later, will zero out our horizontal velocity relative to the surface. And then about 10 minutes after that, we make contact with the tag SAM, fire the gas bottle, and then back away.
And we hope to get at least 60 grams of sample, and then we'll be able to store that and bring it back down to Earth.
But there are several things that could go wrong, and we also have to be prepared that we won't be successful on our first try at Nightingale.
We don't only get one shot at tag, we actually have 3 nitrogen bottles on board the spacecraft, so we can potentially do 3 tag attempts if needed. We go through several what-if scenarios, and this is how we actually prepare for a lot of our contingencies.
So we've had to look all around the surface and identify the rocks and boulders that if the spacecraft were to tip over up to 25 degrees, it could come into contact and be damaged.
We had to develop a hazard map, which we program into the computer and says, if you're getting too close to those hazards, we'll do a wave off, we'll back away from the asteroid, and we'll come back and do this another day.
Everything might work perfectly. We come down, we touch the surface just where we want to, we fire the gas bottle, but the area we contact is covered in large rocks. Those rocks would prevent any fine-grained material from being stirred up and captured in the tag SAM head. Another similar scenario is if the tag SAM were to touch on the edge of a boulder and become tipped up. In that case, when the gas bottle fires, much of that gas escapes out the side, not churning up the material that we want to capture. The day of tag is going to be really exciting, but the excitement for our team doesn't end there.
We have to verify that we have a proper sample.
First, we're going to image the tag SAM head by sticking it in front of one of the cameras. Then we're going to do a maneuver called the sample mass measurement, in which we stick out the arm and we spin the spacecraft in order for us to decide if we've collected enough mass to be able to stow the sample and return home, or if we have to try again.
This is the culmination of a lot of work. It's probably one of the most exciting missions that I've worked on.
It is really exciting to know that we're finally going to be able to touch the surface of the asteroid and collect the sample to return back to Earth.
Whoa.
Dude,
That's
we're
so
amazing.
cool.
Look at us. Look at us.
Right? Talk about like human ingenuity, right?
Yeah, I mean, just like spinning around to figure out how much rocks you got. Like, come on. It's good.
That's pretty cool, right? Using centripetal force, like how basic.
Yeah.
Um,
I mean, do you know, do they have like solar, like how are they fueling it?
that's a great question. Let's find out.
'Cause it's
That's an
been
easy-
going around there for 2 years and they have enough everything to make 3 passes at it and then come back. That just seems like they're doing something right.
Let's find out. Okay, here we go. You were right. 2 solar arrays generate between 1,200 and 3,000 watts. Ion batteries, lithium ion batteries, and a propulsion system. Hydrazine.
2,000
Yeah, that's a lot of thrust.
pounds of gas.
Yeah.
Wow.
3,000 pounds.
So this thing is a heavyweight.
Wow.
That's pretty cool. Yeah, so it sounds like they're like recharging the batteries whenever they can and using this hydrazine monopropellant system to move it around. So 2 things came to mind when they were talking about all the difficulties in landing the OSIRIS-REx spacecraft. So the first thing that came to mind was the successful landing of the Curiosity rover on Mars. Maybe you guys remember, I think it was called like the 7 minutes of terror, when this spacecraft like actually went into the Martian atmosphere, hovered over the surface, and then actually lowered the rover on a big crane, and then like set the rover down on the surface, cut the cable, and then like blasted off to become an orbiter, which is pretty amazing. And it all worked flawlessly, right? It couldn't have been a more like perfect execution. But Mars has a pretty big gravitational field. It's a perfect sphere, more or less. There was a nice flat, sandy spot to land. And in contrast, the attempt of landing on the first comet didn't go so well. This was, what year was that? It was called the Rosetta mission.
Oh, yeah.
So, yeah, so launched in 2004. It made it to this comet 67P. I'm not even going to try to pronounce this last name. My apologies. Anybody want to take a stab at that?
Churyumov. No, it's not. I can't read it because it's all blurry.
Oh, sorry.
Gerasimenko.
Gerasimenko, I like it.
Gerasimenko. Okay.
So they had a successful touchdown with the Philae lander, but unfortunately, what happened is that it didn't stay down. It bounced, and it bounced into the shadow of a big cliff.
Right.
And they couldn't supply it with enough power within a few minutes, and they lost contact with it. I thought they might show the picture. There's a famous picture of the arm of the lander. Yeah, here it is on the Guardian. Right, so you get to see like just 1 foot of the lander there, right next to this big cliff face. But I mean, the comet was way more misshapen than asteroid Bennu, right? This really weird oblong shape. So almost a successful landing on a comet. So I feel like that's what these folks are up against. The difference between landing on a much larger surface like Mars compared to landing on something pretty small. I think asteroid Bennu is quite a bit smaller than this comet. I think it was comet 67P. Let's see how big it was. size. Oh yeah, so this thing was a mile across.
Wow.
1.2 miles across, and asteroid Bennu, 861 feet.
Huh. Wow.
Yeah, so this thing is way smaller, so much weaker gravitational field. I think it is going to be tricky. So what do you guys think? You think they're gonna nail it in their first attempt to get this sample? You think it's going to take 2 attempts?
I think. Yeah, I don't know. I think that with the 3 chances they're giving themselves, I think that they've got a good chance of it overall being successful. But who knows? I don't know about. I think that they were really smart about putting the extra gas on there, and I think they probably have an idea that it might be pretty difficult, a lot more difficult than just
Yeah. Talk about planning ahead, right?
Yeah.
Matt, Ryan, what do you guys think?
Yeah, I agree with Dave that overall it'll be successful, but whether it's going to happen on the first, second, or third try is sort of just a matter of fortune, I think.
No, it's happening first try. Yeah.
Yeah, I was gonna say that too, man. I think they're gonna crush it. I think they're gonna get it on the first try. I think everything is gonna be flawless, and they're not only gonna land in a perfect site. There aren't gonna be any rocks. They're gonna get exactly the content they want. It's gonna be perfect execution. First time, touch and go, and coming back to Earth.
Yeah, there's no cliffs this time, you know?
No clip. Well, they did mention though that if it tips, there might be some problems.
Nah, they'll be fine. They'll be fine.
Yeah, I'm feeling pretty confident as well. Not that I really have any specific reason to have that confidence other than I think these guys have thought through a lot of scenarios.
Yeah, the moment they said they just have to spin around to figure out how many grams are on there, I'm like, they thought it through. It's going to work out.
That's pretty ingenious, right?
Yeah.
Because we know the mass of a spinning body.
Yeah.
And we know what the velocity should be depending on its radius. Like, that is really cool. Thank you, Isaac Newton.
Yeah.
Right?
Yeah.
I find that pretty impressive as well.
I think it would have been funny if they would have just had like a cup of water on board, and then they just like used like the displacement of water to do that. That'd be kind of
that would have been tricky in the vacuum of space.
gravity. Yeah, I know.
There is that. They would have had to have maintained 1 bar atmospheric pressure for the last 4 years.
Stranger things have happened.
And then I guess that begs the question, how would they have got those samples in the water without losing the pressure?
Physics, man.
Yeah, physics indeed.
I don't understand this 1 in 2,700 chance. Like, what's throwing us off? Like, what you think? I guess it's just that there are other things playing factors that we don't actually know, and so we're like trying to take those into account.
I don't know this to be certain, but my understanding is that this goes back to the classical 3-body problem. There's no way to know the gravitational interactions of 3 bodies or more, right? So the laws of gravitation that we have only work with 2 bodies, right? Sun and the Earth.
Yeah.
Jupiter and the Earth, like whatever you want. But there are way more than 2 gravitational bodies that are going to be impacting the trajectory of this asteroid.
Yeah.
So I think that's the issue. because of the 3-body problem, all we can do is compute 2 at a time, right? And then we add up the probabilities of all the other sets of 2. And I think the error bar gets large very quickly.
So could you essentially make like a probability curve and give like close to 100% certainty that it'll be within this range? Like how, you know, maybe it's like 1,000 or 10,000 kilometers away from Earth. Could you like give a window, sort of like going back to like uncertainty in quantum mechanics, you have this like bell curve, you know, to specify a location, but with minimal precision.
Yeah, and my guess is they have something like that. We're just kind of seeing like the public version of those calculations right here. There probably are far more precise and accurate probabilities at per unit time, right? But my guess is even with those, there are, like you said, I mean, it's a probability curve. There are still error values. So yeah, maybe it'll happen in the next 50 years and we'll get to know whether or not it actually contacts Earth in one of its passes. I think it swings by Earth several times over the next couple of 100 years.
I mean, if we can get rocks from it, we can land on it and destroy it, right?
I think there are actually some spacecraft designed to disrupt potential asteroid impacts.
Yeah, that's what I started reading about those, and I heard about whatever the asteroid was that could potentially hit us in the next couple 100 years.
Yeah, let's see here. Satellite crashes. All right, here it is. Is this it? Oh yeah, here we go. Okay, so the DART mission, planetary defense mission. Oh, come on.
Part of the Space Force.
Any of you guys have a National Geo account?
Ryan?
You got one hitting up with that mustache.
Oh man. All right, I'm gonna do it.
Okay.
I'm gonna just sign us up here.
Get a free trial.
Yeah, there's got to be a free trial, right? Samuel@WyomingStargazing.org. Check my over the next few days. Oh, there we go. I was like, that's not gonna work. You're like 12 minutes left right now. Okay, so here's the DART mission. NASA's first planetary defense mission will demonstrate asteroid deflection by crashing the spacecraft into an asteroid at about 14,500 miles per hour.
All right.
That's pretty cool. So let's see, this was just a few months ago. What did they learn? So it could have potentially left a 6-mile wide crater on the Earth.
Wow.
At least a mile wide. Within 5 million miles of Earth. So, I mean, that's pretty far away. That's 20 times the distance to the moon.
Wow.
So the double asteroid redirection test. Slam a spacecraft into the smaller of 2 asteroids orbiting each other. Any change in the smaller asteroid's orbit will be easy to measure from Earth and will provide a good indicator of whether it's been successfully deflected.
Yeah, because like the earlier you deflect it, the less you'd need.
Right, because the amount of deflection increases over time.
Yeah.
Yeah, so if you do it when it's really far away from the Earth, the 2 pieces pass by Earth. Let's see if there's any updates on this.
So we're gonna if I'm hearing this right, we're gonna actually test this on an asteroid that's coming by and see if we knock it out of its trajectory a little bit.
Yeah, so okay, here we go. So it doesn't get launched until July of next year.
Yeah, totally.
So this spacecraft is gonna rendezvous with this asteroid in October of 22.
It's it's about the size of a refrigerator.
Large fridge.
They're using the old fridge from our apartment.
And the idea is, yeah, hopefully just the momentum of the impact will be enough to change the orientation of this smaller asteroid enough to potentially deflect it away from Earth.
It says right before it crashes, it's going to eject a camera to take pictures.
That's pretty cool, right?
Well, if we can do that, I feel like that can let people feel a little bit more optimistic about our future with all of these objects, you know? Like if we could prove that it is possible to do it, I think that's a huge thing. That's a really big deal.
I say we just make a Death Star.
Also, I think that's probably maybe that's the next project. I don't know.
Well, I remember reading actually about a different mission. I think it might just still be hypothetical. It worked a little bit differently. So there was a spacecraft that would fly out to an asteroid or comet that was expected to hit Earth. Just before that spacecraft impacted the object, it would send a projectile detonation device, some huge amount of TNT to create a crater just where it was going to impact. So then it would fly into the crater and detonate some kind of nuclear device to like rupture the object. That was the other thing that I read about years ago. I don't know if that's actually still being talked about. This seems a little bit more benign, right? No explosives. You just smash the spacecraft into it. So we don't create any, radiation from a nuclear detonation. And it sounds like we're going to do a follow-up on this one. Another spacecraft is going to go out there in 2026 and see what happened. That's pretty cool.
Sweet. Well, that nuclear idea does sound kind of cool.
It is interesting. Although I honestly hope they don't do that.
Yeah.
I actually think that what we should do with all of our nuclear weapons is similar to how they dealt with it in one of the Superman movies. You guys remember that?
I don't know. Which one?
This might have been before your time. This was probably like 1980s, maybe.
Okay.
Maybe 90s. I can't remember. Superman basically gathers up all of the nuclear weapons in this huge net and flies it out to the sun and just throws all the nuclear weapons into the sun.
Nice. Taking away the toys.
Right? I mean, that seems like a pretty simple solution. Why can't we do that?
Throw garbage into the sun too and everything else.
That's actually been considered.
Yeah. I mean, yeah, that's a good idea. I mean, I guess it would be expensive, but
I think that therein lies the problem. There's a slight cost-benefit analysis that needs to be done there, and maybe the numbers don't quite work out.
Maybe when we start asteroid mining, if we can get that going, then we'll have enough money. Then we can start.
The amount of fuel that we would expend would far outweigh the number of trash that we have to get rid of.
But you'd have to make one of those.
Interesting.
You'd have to make one of those space elevators.
Oh yeah, I've read about those.
Yeah,
those seem realistic.
I mean, that's the only way you're gonna get garbage in outer space.
Yeah, you might be right. Maybe though, if we get fusion reactors going and we get good clean energy, that's a game changer.
Oh yeah.
Could be.
That'd be sweet. So much to look forward
to. Oh yeah, here's the other one that I was talking about.
Small as Diddy Moon.
Detonating a nuclear bomb.
Wow.
So it is legit. Where'd that just go? Yeah.
Looks like a country island.
Nuclear explosion on an asteroid surface would risk creating a shotgun blast of fragments still heading for Earth. Seems problematic.
Just a tad. We're gonna have to blow all those up.
Oh yeah, look at this last liner they've got here.
You see this with climate change, this pandemic, even this planetary defense problem. Small amount of preparation makes a big difference. Nice.
So another plug for planning ahead, like bringing those 3 gas canisters to have 3 attempts on asteroid Bennu.
Yeah, exactly.
Cool. Well, we're just about out of time. Yeah, when we come back next week, I think we will know whether or not this collection of the sample of Bennu was successful or not. So stay tuned for that, October 20th. But we'll bring you the update 2 days after that on next Tuesday, or excuse me, next Thursday, for Astro-BS.
Sweet.
Nice.
Thanks for being here, guys. I appreciate your time.
Sure
No
thing.
worries. Thank you to all our loyal viewers. We couldn't do this without you.
Yes, indeed. Thank you for mentioning that, Dave. Yeah, and if you haven't liked us on Facebook, followed us on Instagram, and subscribed to our YouTube channel, you should definitely do that because it helps us out. So yeah, we appreciate you being here, and thanks so much for joining us for Astro-BS. See you guys next week.
See ya.
See ya.
Later on.